Hi, welcome to another 4AC video. This time we look at quiz 6, which we have just completed, and the solution to question 2. Now, question 2 has the circuit shown in figure 6-2, and part A, it wants us to calculate the time constant of the circuit when the switch is moved to terminal A. And it wants us also to calculate the initial value of the current and the steady state values of the current Vc and I flowing through to the capacitor. And the second part wants us to sketch the waveforms of IT and Vc after time 0 or greater, and we are supposed to label all the values and the axis clearly. Alright, let's see how we can handle this question. Alright, when the switch was moved to terminal A, the effective circuit is just R1, R2, and the two capacitors. So therefore, the total resistance is just R1 plus R3, which is 200 plus 200. That gives me 400 ohms. The effective capacitance total, the total capacitance, will be just C1 plus C2, which is 10 plus 10, which is 20 microfarad. Therefore, the time constant tau is just RT plus multiplied by CT. So it's 400 ohms times 20 microfarad. That gives me 8 milliseconds. Now then, what we want to know is what are the initial values of I and Vt. This means at time t is 0. Now at time t is 0, the current will be just forming, so it will be just V over R1 plus R3. That is equals to 20 divided by 400. That gives me 20 volt divided by 400. So 0.05 ampere. And the initial voltage of the capacitor is still just building up, so it's 0. So the waveform for this will be the voltage of the capacitor will be building up. We will look at that, where the highest voltage is 20 volt. Is 0. Whereas for current, the current flowing through, it started with the maximum and then taper off to be 0, right, corresponding to when it's 5 tau. The maximum current level was 0.05 amps. Alright, so this is the two waveform of the capacitor voltage and the current flowing through to the capacitor when the capacitor is in the charging phase. So this is the RC charging phase. Alright, I've seemed to have left out the steady state value. Now, if I were to look at these two waveforms, I can conclude that the steady state values, that means after time t is 5 tau, will be I 0 ampere and V after 5 tau is just 20 volt.